In this series of videos I'm attempting to repair a Hazeltine 2000 smart terminal. In fact, I'm trying to repair two of them. This is the chassis out of the second unit. The first unit is now pretty much up and running, just a few small tasks left and then that will be complete. So I've decided to turn my attention to the second unit, and this is in pretty much the same state that the first was. The chassis had a real rough life. It's got a lot of bent parts. Almost every mechanical part is bent. It's going to need a fair amount of work to get this back into a reasonable state. The front plate for the switch is bent, so you can see it's pushed back. These should be straight. There's another plate on the rear of the machine similar to this, and that's been pushed in as well, so that'll need straightening out. This is bent all the way across, and I'm not quite sure how they've managed to do this, but it's really in quite a poor condition. The card rack is also bent. It wasn't the first one. I needed to take it off and straighten it out, and I'll need to do the same thing here. And the CRT cage is twisted, so I'll need to straighten that out. And I'm not quite sure how this was achieved, but this heatsink you can see here is, I don't know if you can see it on camera, but it's kind of bent in and it should be vertical, and there's a big capacitor down here that this should be screwed onto this side, the left hand side as you look at it, of this power PCB, and then the screws should mount it to the board. For some reason it's been taken off and it's just held in place with some cable ties. Now I suspect what happened here is whatever the original damage was that pushed this heatsink across, it would have pushed this capacitor, which would normally sit in here, across and force it against this board. And I think that someone carried out a repair in the past, and rather than bending this back straight, what they did is they took the capacitor off the board and just put it down here. Now it's not ideal having these long leads connecting the capacitor through to the board, so I'll be putting that back onto the board where it should be. I'll straighten the bent parts out and try and get it back into a reasonable state. I'll need to do some more repairs on the CRT drive board. It's mostly repaired, as are all the PCBs. As I went through the first unit and repaired the PCBs, and I was set up to do each one, I slotted in the second set, or the boards, the same boards from the second set, and repaired those at the same time. Didn't show those on camera, but same types of faults, and went through and made sure that they were all working as best as I could. So what I'm going to do with this one is repair the chassis, carry out all the repairs, all the mechanical repairs, and then I'm going to test the power supplies to make sure they are correct, and then I'm going to plug all the boards in at once. I'm fairly sure they should work. As I said, I have tested them all individually already. So I won't show this on camera. It'd be fairly tedious, just going around straightening a lot of parts out, taking them off, trying to get them back into a good state. I've already given this a really good clean. This was filthy, so it's already had a very good clean, and it's come out quite nicely. It's just much more pleasant to work on after it's been cleaned. So I'll get this done, we'll get back on camera and start refitting the parts to it. I'm making good progress with the chassis. I've straightened up a lot of the parts. I'm now working on this heatsink bracket, and you can see how badly bent it is. This should be straight. You can see this section here should be straight. You can see it's bent over at this point, and that's what's causing the heatsink to be pushed too far across. So I need to straighten this out, get it so that the heatsink is sitting vertical, and then I can put the capacitor back onto the power supply board in the correct position. So I've straightened this bracket out. The heatsink is now sitting nice and vertical, and what I can do now is put the capacitor back into its correct location. There's now much more space between the back of the heatsink and the PCB, so there's now space for the capacitor to go back in. I suspect that's why the capacitor was moved rather than straighten the bracket out. Maybe whoever was doing it didn't realise this was bent, and rather than straighten this out, they moved the capacitor, so I'll just put that back where it's supposed to be. Other things that are bent on here that are kind of strange. I'm not quite sure how they managed to do this. I'll just move the camera across. So this is the rear portion of the frame that the CRT sits in, and this is bent. It's kind of bent from here back. This is splayed out. It probably doesn't show up very clearly on camera, but this has been bent. Not quite sure how they managed to achieve this. Not really sure what's happened to this. I can't quite figure out how they've managed to bend these parts in the way that they're bent. I suspect it happened at different times, but this has had a really rough life, so I need to straighten this part out as well. As I said, almost every part on here is fairly badly bent up, so there's quite a lot of work left to do yet, but I'll just work through all the various damage and try and get this chassis back in reasonable state. So I'm now relocating the capacitor. I've cut the cable ties. These were just looped around part of the frame, so I've cut the cable ties. I can now remove the two wires that hold this, or currently hold it in place or connect it, and this then screws onto the board. So you can see there's not a lot of clearance between the board and the heatsink, and with the heatsink being bent over, I think that's the reason this was moved out of the way. But now we've got the chassis straightened out, I can put the capacitor back onto the board where it's supposed to be, and it will work a lot better being screwed directly to the board. So I've got the capacitor removed from the chassis. If you're interested, it's 15,000 microfarads, 25 volts, and I've had it hooked up to the bench supply for the last hour or so while I've been working on the other things on the chassis. And it's drawing about 1 milliamp leakage current, so that's fine, that's not a problem at all. It's quite high by some standards, but for this type of capacitor that's perfectly acceptable, and it looks like the capacitor is working fine. I've also tested the actual capacity, and that's fine as well. It's up around 16,000 microfarads, which is quite good. And so what I can do now is discharge this and get it fitted back into the chassis, and hopefully it will now fit in the space that's there. Well, things became a bit clearer when I tried to refit the capacitor to the chassis, and it's the wrong capacitor. It's got the wrong pitch connectors, so I think that's why someone tacked it on with a couple of cable ties. Presumably the original capacitor failed, and this is the only one they could find. I don't really want to leave it on the end of a couple of wires. It might be alright, but it does reduce the effectiveness, and on a piece of equipment like this, ripple is quite important. So rather than just leave it on the end of the wires, I popped over to the workshop and I made up a spreader. So this just fits onto the terminal of the capacitor. You then put a screw into the capacitor, you rotate this to give the correct pitch between the two screw connectors, and then a couple of spacers, and you can screw this directly onto the board. This is a tapped hole at the end here, so it just screws on like the original capacitor would. And it looks much neater, and of course it will work a lot better like that, and it's I think a more effective repair than leaving it on cables. The cables would have been fine, but as I say, it's just far better to try and restore these as much to original as possible. So that's the capacitor bolted back in place, and as you can see it looks much better, but also it's much more solidly mounted. So just to clarify, the spreader bar fits onto one of the posts on the capacitor. There's a recess in it, so it mounts very snugly onto the capacitor. There's a threaded hole in the end of that spacer that the bolt going through the board goes into, and then there are two spacers, a different length of course, because you have to take into account the thickness of the spreader bar, and then you just put the two bolts in as normal through the back of the board, and it connects the capacitor directly to the board. So very nice, snug, secure mounting. It's not going to go anywhere, and it looks much better than having something just tacked onto the side. And it is the right value capacitor, it's just got the wrong pitch spacing for the connections. So the next step is to get the power supply tested. So I'll refit the regulator board, get the supply tested, and then in the next video we'll look at refitting the board set. That's most of the repairs complete on the chassis. I just need to make a new insert for the knob and replace the mounting standoffs for the CRT control board. I've got the regulator board plugged back in. I've checked all the fuses, checked all the basic wiring, so done the usual static checks, looked for shorts, checked the bridge rectifiers, that sort of thing. Obviously checked the capacitors, and everything seems fine. Can't find any shorts. I've checked between the power rails and ground on all the backplane power connections. They're fine, so I'm going to power this up. Now this unit's still set to 120 volts. I'm going to leave it at 120 volts, and that's how I'm going to test it. So I've got the bench transformer turned right down to 0. We'll turn it on, and as with the first unit, there is a cut-off relay, so we'll hear that buzzing as I start to increase the voltage, and before we get to probably 70 volts or so, it should kick in and we should see an output voltage. I currently have the test meter connected between ground and the plus 5 volt rail, so we should see slightly over 5 volts appearing on the meter. So we'll get this powered up. That's the relay you can hear starting to buzz. That's kicked in, and we do indeed have 5.2 volts. We'll go all the way up to 120 volts. So that looks fine. Plus 5 volt rail's fine. We'll look at plus 15 volts. Again, that's fine. Plus 12. It's a bit high, but then there's no load on it, so it would be, and then the same with minus 12. It would be probably a bit too high, but not too bad, very close. So okay, well, all the supplies look good. That's it for this video. Before the next video, I'll just make up the insert for the knob. I'll refit and test the CRT board, and what we can then do is refit the entire board set, and we'll do that in the next video, power it all up in one go, and see what happens. As I said, I don't have the CRT for this unit, so we'll hook it across, and I'll use it with the CRT out of the first Hazeltine that I've repaired. And hopefully this is very close to working. As I said, I've tested all the boards. In theory they all work, but you can't really tell for sure until you put them all into a machine together, power it up, and see what it does. But should be quite an interesting video, and hopefully by the end of that one we'll have 2 of these Hazeltine 2000s up and running.